Afternoon to all. I welcome you all again in the third session of the AICT Training and Learning Academy's 1-week faculty development program on smart cities organized by GEC Bilaspur. I am overjoyed to take this opportunity to introduce our resource person of the session, Dr. Debashish Sanyal. He is currently working as professor and head in Department of Architecture in National Institute of Technology, Raipur, Chhattisgarh. He obtained his PhD degree from TMN University, Nagpur in 2020. His areas of interest are intelligent super tall buildings, energy efficient housing, industrialized mass housing, and indoor air quality. He has a vast administrative, academic, and industrial experience. He has authored various research papers in several national and international journals. He has presented various research papers in national and international conferences. He is life member of Indian Society for Technical Education, New Delhi, associate member, the Indian Institute of Architects, Mumbai, life member, Indian Institute of Public Administration, New Delhi, and many more. He is awarded Justice Mahapatra Award for Research by Rotary Club of Raipur, Central Raipur in 1995. Also awarded A3F Teacher Award by A3 Foundation, Chandigarh in 2019. He also earned the award for the valuable contribution in engineering and technology, the Institution of Engineers, India, Chhattisgarh State Center. We will be addressing this session on topic design of smart buildings to planning of smart city, a necessary transition. Without further ado, I welcome Dr. Debashish Sanyal for his address. Please, sir.
Yeah, welcome all the participants. I hope that my screen is visible now.
Yes, sir, it is visible.
Okay. Now, first of all, I congratulate GEC Bilaspur to have a FDP on smart cities. The smart cities is a very necessary topic which has to be addressed at various levels. And I have seen the list of experts. They are coming from different walk of life. Why we want to start with smart city? That is a big question at this point. So first of all, I am explaining that there should be designing of smart buildings to planning of smart cities, which is a necessary transition. Now, this is the genius loci. That means the spirit of a place. We have space, people, and place. Now, all these three are to be taken. That means the space and people to be taken, and they will be going for a functional place. There has to be efficiency, effectiveness, and function has to be expressed. Now, this is the workplace paradigm. That means in a building, there can be environment, that is climate, building physics, which has space and climate complement each other. We have passive design principles, solar architecture, and building physics engineering. Also, there is infrastructure adaptability. Systems assist with space utilization and management and are designed and installed in a manner that allows the rapid reconfiguration if there is a change in the organization need. So we have a term called building intelligence. This started somewhere in 1997 onwards. And this climate of outside is monitored and managed by building systems. Then it will amend the environmental condition on the basis of real-time occupation densities. Now, this is a scene within an office. In a conventional office, you can see that what's really happening. Some people will be feeling very cold. Some people will be feeling very hot. Some people will be thinking that there is too much noise. Some people will be thinking that it's very quiet. Some people will be needing fresh air. But whether our buildings are providing all this, then this is communication. Nowadays we have mobile, but earlier is it a effective communication between two people? So what we need is smart buildings. Before starting smart building, we must understand that smart cities cannot be imagined without smart buildings. First components are your buildings has to be smart. Only then your city can be smart. Now, what is smart building? Smart building is dealing with building automation, safety, and productive environment. Smart building, a building that provides productive and cost-effective environment through optimization of its four basic components: structure, system, service, and management, and the interrelationship between them. What is the need? 40% of the world's energy is consumed by buildings. 21% of the greenhouse gas emission come from buildings. And if you use smart technologies, you can save up to 40% energy in your buildings. So further, 58% of office workers think that their building is not designed as per supporting their company's business or their own job function. 30% is the organization change value. Then 24% of staff is influenced by the comfort, surrounding systems, environment, and layout. And then energy is the largest manageable cost of many companies, with buildings accounting for 40% of world's energy use. So now we come to the introduction of smart buildings. These smart buildings will help the building owners, property managers, and occupants realize their goals in the area of cost, energy management, comfort, convenience, safety, long-term flexibility, and marketability. Automatically sense, infer, and act in order to balance user comfort and energy efficiency, occupancy, time of day, various other inputs, resulting in significant reduction in building energy use. These smart buildings will be having a automated control. You see that those red points within your residence are actually smart things. You already are starting to hear about IoT. People are saying that IoT is the next future, AI is the next future. We were learning this since 1997. This is not a new thing, but it came into fashion just now. Now these all the smart features, that means security alarm, motion detector, door control system, they are talking with each other so that a coordinated approach is possible, and the occupants will have a remote control by which he can control everything as per his own choice. Now, learning ability. Learning ability means the smart building will learn from the data of your use. Whatever you are facing, or you are ordering, or you are doing something, those things are data logged in the smart building, and it will try to replicate the same things daily or as long as the environment and occupant are similar. So this helps more in learning something and doing something. Now, this is the schematic diagram of a smart building. Smart building has characterized here, that is building with a brain. The major services system: lighting, lifts, 24/7 monitoring, HVAC, energy, utility monitoring, access control system, security, fire, all these are controlled by a centralized brain or smart building, what we called as facility management system, and in which the facility manager looks after the building and controls them in a uh, one console kind of thing.
Professor Sanyal,
Yes, sir.
your slide is not moving actually.
Oh, yeah, I will check. Now, I am into slide 12. It is not coming.
No, only the first slide that is showing actually, and
Okay.
that is also not full slide.
Okay. So I will take down and start again.
Yeah. Now it's coming. Now it's coming.
Now it's coming.
Now, yeah.
So
Make it full screen.
yeah, I'm making full screen.
Yeah.
Now this is second slide. You are not able to see?
Now it's moving, sir. But make it full screen.
Okay.
Yeah.
From my side, it's full screen. Just a minute. Right?
Okay. Now it's moving, but no problem.
Okay.
Hmm.
So this is my second slide on the workplace paradigm.
Yeah.
And right. And next, I was showing that what is happening, really happening within the office. You can see that people are not feeling comfortable with the conventional office.
Yeah.
Then
Now it's moving.
yeah. And then next, I was showing that this is the effective communication system, and this is what a smart building has to be. It has to be Wi-Fi, and the building should interact with each other, smart grid and all. So that this is the definition of building that provides a productive and cost-effective environment. And that is the need, as I explained, that the need of world's energy consumption. So here the need of organizational changes, productivity, inefficiency, all that. And here we are seeing the different control systems. You see that red dots are the smart things which are being controlled by a remote. Is this okay?
Yeah.
Yeah, okay. So now this slide gives you a view of what is a smart building. Smart building is having a building with a brain, and all the services are being controlled from one point of the building, and from where we can see all the services. If there any problem, there is a lift breakdown or any water services or anything which needs maintenance or anything which is not working smoothly, can be controlled with a brain. Also, this brain gives all the data, whatever happened in the building, it logs all the data and can show you the occupant that these are the things happened in the building. Now, why we are going for smart building to smart cities? Because these smart buildings will have the integration with the smart grid, and then it will connect to the smart city. This is a schematic diagram. Here you can see that dampers, indoor air quality services, air filters, air handling units, fans, operator station, everything will be ultimately connecting to the smart city. Now, what is the aim of a smart building? The technology allows us to operate the building more efficiently, to construct the building in a more efficient way, to provide a safe environment, to provide an energy efficient and sustainable environment. and to provide productive and healthy spaces for the occupants and the visitors. Now, we have, this is basically electronics and IT. Many new buildings are being built with complex systems and then sensor and controls, which is necessary to the building users as well as administrators. So, what is a smart building? That is the use of integrated technological building system, communications and controls to create a building and its infrastructure which provides owner, operator and occupant with an environment which is flexible, effective, comfortable and secure. Now here, why we suddenly needed a smart building and its design and all that? First of all, if we already have a building and we want to make IoT enabled building or technology enabled building sort of, so we need a huge retrofitting. So instead of that, our building designers or architects should first think about what level of technology is needed in that building, and similar technology they started providing it right from the design stage, so that finally the building becomes automatically smart. Now, how a building can become smart? How can we say that this building is smart? Now, for that, first of all, I will definitely say that everybody of you must be having a smartphone in your pocket. Now, suddenly, how the phones become smart? What is the term smart here? That means it is taking some decisions. Your mobile phones are actually taking some decisions. If it comes in a Wi-Fi environment, it will update itself. Its apps will start working without asking you. So that means there is a term of intelligence in it. So smart buildings should know that what is the environment they are in. Number two, they should be able to activate themselves that these are the things we should do immediately. Number three, it should cater all the emergencies, exigencies and disaster resistance features. And number four, the other things like energy management system and building automation system it will use for the occupant's comfort. Here the occupant can have own choice of environment, HVAC, lighting, whatever choice of music, whatever choice they want, they can give, so that the building will comply with the occupant's request. So that's why this is called as smart. General buildings do not cater to these things. They do not have an intelligence, or they do not have a system in which they can cater automatically. And here we are talking everything which is somewhat automatic features. You can see that automatic notification, monitoring and control, security and alarm, local servers. Now these are the components of a smart building. There are energy management system, lighting management system, security system and fire safety, telecommunication and office automation, LAN, cabling management, intelligent management system, maintenance management system, and computer-aided facility management. Now, some of the things you must be knowing already, and some of the things are somewhat new, but this all makes a building smart. The major categories are energy efficiency, life safety, telecommunication, and workplace automation. Now, nowadays, because we have advanced communication facilities, so some of the things PABX and all has already gone, and now we are into email and WhatsApp and all. Smarter building, the potential business benefits. Building has to be smarter, intelligent, interconnected, and instrumented. The identify or strategic savings will be there. This is a business proposition for the people who want to make buildings smart. So there will be 10 to 20% saving in space utilization, 10 to 30% saving in energy and carbon monitoring, then asset management, what asset you are locating to which person, there will be 10 to 20% saving. So all this helps. And also there is a redundancy. What's important? Smart buildings should improve occupants' comfort, achieve energy saving wherever possible, avoid or reduce damages by sending warnings, and increase security compared to the traditional building. Now, how? Using the cheapening power of communication and computing we have at our reach today and forcing the subsystem to work together, not independently or even against each other, we can achieve a building which is smart. Now, what is the commonality between smart and green buildings? We know that nowadays we have sustainable buildings as a requirement, then green buildings as a requirement. So this is the overlap, and I will only read the overlap portion, that means dark green portion. Here you can see that smart buildings offer optimized energy performance, additional commissioning, measurement and verification, CO2 monitoring, controlling of systems, permanent monitoring of systems, and innovation in design. These are common things with a green building. Now, comparison within a ordinary building and smart building. The smart building, here we called it as a intelligent building or IoT enabled building, but ordinary building is termed as dumb building. There will be different room conditions depending on the changes of environment conditions. That means one room can be hotter, one room can be having more humid, but smart buildings will adjust the inside functional aspects such as lighting, ventilation, air conditioning, and automatically with the changes of the environmental conditions which are controlled by the computer. The cost of construction of a smart building is very high as compared to ordinary building. But in case of ordinary building, a building service engineer and architect is enough, but security system, communication system are to be coordinated and automatically controlled by computer workstation, whereas in ordinary building there is no workstation. While planning a smart building, a building service engineer, an architect and hardware engineer is required. Now, what about the cost? The cost of smart building is high, but it will repay its saving within a payback period of 7 to 9 years by way of energy saving only. If you take only one feature, that will give you your money back, whatever extra you have paid for making those smart technologies, incorporating them within the building. Now, let us see a scenario. Up to this, I am okay? You all are listening?
Yes, sir.
Okay. So, next slide, you give your full attention because this is the smart home example. A scenario such as I am home could be triggered by pressing one button on a keyring remote control from your vehicle. As you approach the driveway, the control system receives the keyring remote controls command. This will then trigger a pre-programmed sequence of functions. For example, starting by turning on the light in the driveway, garage, hallway, kitchen, disarm the security system, opens the garage door, unlock the interior garage entry door, adjusts the heating cooling to a preset temperature, turns on the whole house audio system, playing your favorite CD while drawing you a bath. Now, this is a scenario which can be activated by your one pressing of a button. Looks interesting? What is happening is the control system is programmed to meet a specific user requirement, initiate sequential automatic operation of the home system in response to one button command based on the situation and or time. Now, let us see another scenario. At 7:30 a.m. and you awake to the sound of your favorite CD playing in the background, the lights in your bedroom switch on, fading up to allow you to wake up in your own time. The downstairs intruder alarm system is deactivated. In the kitchen, the coffee machine turns on to make a drink. The ground floor curtains and blinds open, and the towel heater in the bathroom warms the towel. And you have not even got up yet. So this is the second scenario, and this simple example demonstrates how a smart home technology will change people's life. Designing systems that group together and automate everyday simple tasks, improve the quality of life, and reduce the stress level. Automatically now there is a home appliance available which will dust your floors. It is having a automatic vacuum cleaning system. If you on, it will go to all the corners of your room and it will vacuum clean your house. So you understand that how much convenience will be offered by these smart gadgets. Now we come to the building automation system. Building automation system comprises of electronic equipment that automatically performs specific facility functions. The commonly accepted definition is comprehensive automatic control of one or more major building system functions required in a facility, such as heating, ventilation and air conditioning system, cooling, lighting, power, lift, security, etc. This integrates the traditionally separate function of temperature control, energy management, fire and security under one common operation. These are the function of BAS. BAS core functionality keeps the building climate within a specific range. Whatever climate conditions are there in the outside, we will have inside the totally comfortable condition. That means temperature within a range, humidity within a range. Provides email or text notification to building engineer or maintenance staff if anything happens. Suppose lift door is not working. It will immediately give a notification to the building engineering section or the facility manager. Provides lighting based on an occupancy schedule. Now, this is something which is happening in India since long. There is a CMS building in Mumbai, which is their office building, and there if you walk the front corridor, there will be lights will switch on, and as you walk, your the lights which are below you behind you will be switched off. So this way it gives a lighting based occupancy sensors and it will do like that. The BAS functionality reduces building energy and maintenance cost when compared to a dumb building. Then it monitors the system performance and device failure. If anything happens, then the device failures are logged and it will be intimated to the facility manager. Or let us say any of your building services system requires maintenance and the maintenance date is coming near. So an alert can be sounded by the smart building that this part needs maintenance, your lifts need maintenance, your escalator need maintenance. So please do the periodical maintenance on this date or before this date. So this is automatically done. Here we are showing you some innovative or transparent materials, smart glass or switchable glass, also called a smart window or switchable window. Here you can see that the same room with a switchable window, if you press a button, it will be opaque or it will be transparent in the same room. So thereby giving you the meeting privacy between the two. The smart windows work in this way that there is a liquid crystal layer within the glass, and when the current passes, it will either block or when the current passes, it will become conductive coating, so light will pass. So if you turn off the current, the the glass will actually stop. So that will become a opaque surface. So this is a feature. We have how many smart material feature. Next is advanced integrated facet. This is a building envelope that exhibits adaptive characteristics that are in tune with both the physical and climatic conditions of a particular location and indoor environment requirement. Here you can see that hot air is going up and cool air is coming from below. So this will give you a double skin facet. Then there is a what we called as TDD, tubular daylighting devices, transmit the visible light through opaque walls and roofs. There is of course smart lighting, sensors. Most commonly utilized sensors are occupancy and photo sensors. Occupancy sensors are used in detecting the room occupancy and utilized in the room locations such as conference room, toilet, hallways, or storage area. Then photosensors detect the amount of ambient light and use this information to determine the amount of artificial light required to maintain the total ambient lighting at a defined value. Then there is responsive building elements, building components which can be actively used for transfer and storage of heat, light, water, and air. This means that the construction elements are logically and rationally combined and integrated with building services function such as heating, cooling, ventilation, and lighting. Of course, there are new phase change material which can be suitably characterized at a atmospheric pressure. It undergo a phase change and it can remember its original phase. So with the change of temperature, it will again come back to its original shape. And this is the role of life cycle assessment. We generally don't do a life cycle assessment of a building. It has to be done because it will give you the raw material procurement, manufacturing, distribution, consumer use, and post-consumer use, the total cost of the thing, the environmental impact or CO2 impact of the total building. So attributes of smart building, what are the things we are going to control? In general, we have HVAC system, lighting control, lift management, DDC control, emergency power system, hydraulics, refrigeration. All these are taken into integrated building management. The process is, it has flexibility, designed to change, it has an energy efficient design, complete building modeling, focus on building circulation and common spaces. Construction can have sustainable construction practices. Then operations can have integration of all systems. So overall, you will have a real-time energy response and energy information and management system. Next is the technology. You can see that in general, technology is there are various concerts, shopping, restaurant, lodging. All these are different general technologies. Then we have personal comfort control, temperature, humidity, indoor air quality, lighting, acoustics, and then networks, of course. So how to reduce the building cost? Using all these technology, all these services to a minimum level, whatever is required. If there is no occupant, no light or HVAC will be provided into that room. Hello? Yeah, anything you want to say? You are able to see the slide?
It's visible,
Yes, sir,
sir.
it is visible.
Okay, okay. So now we are into system integration. Building management system centralize the operation, monitoring and management of building system such as HVAC, lighting, air conditioning, fire safety, security access. All this is taken and integrated at one place. So the goal is to have a comfortable and healthy environment and reduce the energy cost and maintain high level of life. Now, the topic of energy. What happens that we are already talking about the saving of energy within a building. So what are the factors where the energy is used? In a building, generally space cooling takes 11%, computers take 4%, cooking takes 2%, electronics takes 7%. So these are the percentage of energy consumption required within a building. And the purpose of energy management is, the role is to identify the areas where energy is used in excess and then manage it. Now, this is the building energy management system, and this is my student operating it. You see that my home is a tab kind of thing by which you can see that all the building's different parts are here. You can have a switch on, switch off facility. In Japan, they generally use this in a residence also, and the housewife has this tab in her hand so that without going to the child's room, she can control the AC, TV, lighting, acoustics, or whatever. So this way, this is very popular in Japan, and in India we have small switches available in the living room by which you can actually actuate all this energy management system. Aim is to optimize the use of energy in building by maintaining at the same time the indoor environment under comfort conditions. Basically, it's a computerized system which will attempt to control all or some of the energy consuming operation in a building. The major ones are HVAC, lighting, and indoor climate. Aim is to reduce and management of the building energy use, reduction of electricity bills while increasing the occupants' comfort and productivity, the improvement of environmental stewardship without adversely affecting the standard of living. The focus is on effective management of two of the largest electricity consumer in the building. One is the appliances, another is the lighting. You can see that how many things comes under this. That is the graphic user interface, reports, SQL, dashboard, and all these are controlled by this. Energy management in buildings. Then there is architecture. This architecture is not building architecture. This is electronics for electronics people. 3-level architecture has been designed for detecting the presence of building inhabitants user and understanding their preferences with respect to environmental condition. The lowest layer consists of sensor, middle layer set of AML components, and the high-level AML functionalities will be provided by centralized entity called MEBox. responsible for coordinating the building agent network and performing intelligent reasoning and choosing the adopted energy saving strategy. That means the building will see that where he has to save the energy and how to maintain the optimum comfort condition overall without spending much energy. And these are the system architecture: sensor nodes, WSN gateway, intelligent control server, power line control devices, etc. That's basically, you can see that there are 5 rooms. We have room number A. So room A has everything on, or room E has no occupancy, so everything is off. So all this is done without human intervention. The building with itself try to do it 24/7. And if you have any request, if you are requesting a lighter music or a particular light, mood lighting or anything, it will also take those requests and comply with it. And this is the building control prototype. You can see that form and function, solar power, building scheme, productive workplaces, and then what these trees need water, tree tops. All these things are sensor enabled. So you can have the sensors, and sensors will give you the feedback that what are the things you require in that particular building. Wireless measurement and control. The objective is small multimodal sensing technology that could affect the operation of buildings. Issues are power sources and what to do with additional data points. The method is sensor development and computer simulation of sensor network. Now I can see that this slide is of course old, so nowadays more small sensors are available. Here we are just comparing it with a coin and showing you the size of the sensor. Advantage is higher level of security and safety. Suppose in night time you are going to your kitchen, so the bottom lights of the flooring level will be on automatically, so that you will be having an ambient light and there will be less chances of any accident. Simplified operations for user and administrators. The different kind of facility managers, let us say electrician, does not need a necessarily the use of plumbing. So the layer of electric circuits will be available to him. So this way it will happen. Simpler staff tracking, reduced administrative cost, smart cards. You already know that nowadays this has come into vogue, that you have a single card for your security and of course ATM and everything. Reduce system cost by sharing the infrastructure. Whatever infrastructure is available, you can reduce by renting it to others. Information can be delivered to all interested parties in the manner they need. Increase mobility, not tied to a specialist workstation. And of course, there are SOPs, so there is a minimum training required for all. Suppose I just take an example of a kitchen. If you don't know how to cook, so it will give you the recipe on the desktop automatically as per your choice. It will give you the energy requirement in the wall with a console that you can see that how much energy is required to cook. And let's talk about fridge. I have been to Seoul, Korea in 2004, and they were having a fridge, a large fridge with a two-door, human height fridge. Now this fridge has a water dispenser on the front, by which you can place your glass there and automatically water will fall. That is in one door. But in the second door, there is a window. Window means the window you are looking at present. That means not a building window, but the window 1, 11, 12, whatever version you are using today. It will monitor the inside of the fridge, and whatever things you are taking out from the fridge, it will read its barcode and automatically give an order to the supermarket that this fridge is lacking these components. So please send fresh vegetables to this building. That means a smart fridge. And this was available by a cost of 2 lakh rupees in 2004 in Seoul, Korea, and still not launched in India. So you can understand that how many such features are available which can be used and make the building smart, occupants comfort good, and ultimately it will give you a total smart environment. Now, these are the benefit. First of all, return on the investment, whole life costing, energy efficiency, environment and sustainability, and the productivity of the people will increase. Suppose you want to achieve some goals in the office or in the residence or whatever, you can do it with a more significant manner, because random things, the routine things will be taken care by the smart building. And you can simply say after coming to your home that I want party mode. The building will immediately give light music and give you the proper mood lighting, and then it will reflect that party mood is now on. So this way it will cater to all your temperature, humidity, everything. So ultimately it will become a smart part of yours, just like mobile has become a part of you. Now you are not anybody is not thinking that life without mobile, how it will happen. So the similar thing will happen with a smart building. Fire and life safety, interface, view functionality, security, intrusion detection, access video, then elevators, lighting, energy management, 24/7 monitoring. Suppose somebody's pacemaker is not working, so immediately an alarm will go, backup generation of power will be there. So this way things will happen so that the people inside are safe, secure, and good thing is that you can choose what level of smartness you need in the building. Suppose in an old age home you need certain features, use only those features. So your building need not have all the features, or in an office you need certain different features than residence. So take those features. So this way things can work. So up till now, I explained what is a smart building. Now let us go into smart city. Now smart city is towards a bigger prospect, a smart time, a smart thought, and a smart city. Smart city uses digital technologies to enhance performance and well-being, to reduce costs and resource consumption, and to engage more effectively and actively with its citizens. Now, what is a smart city? The buildings has to be smart, digital technologies are to be in place, and starting the performance enhancement. Harmony and transformation itself touches and transforms our cities from end to end. Smart city has basic infrastructure, uses smart solutions to make the infrastructure services better, and relies on area-based development. Now, these are the components of a smart city. You can see that smart diamond to define the smart city. There is smart governance, smart energy, smart citizen, smart healthcare, smart technology, smart infrastructure, smart mobility, and smart build. Objectives are to provide the basic infrastructure, provide good quality of life, clean and sustainable environment, apply smart solutions, set examples to be replicated both within and outside the smart city, and catalyze the creation of similar smart cities. Why do we need them? India is urbanizing at an unprecedented rate, so much that estimates suggest that nearly 600 million of Indians will be living in cities by 2030. And the last decade, the urbanization growth of India, the speed is largest in the world. So there is more and more urbanization. Urbanization trends will impact the smart city development. Needs from emerging deurbanized cities and corridors will create new challenges and opportunities. You can see that it was urbanization, then suburbanization, then new network city, and now we have branded city. We have different cities called as by name that this city is having this facility. The segments of smart city are smart energy. We have smart grid, asset management, smart generation of electricity, microgrid, district heating, cooling management, gas, etc., distribution, shore connection, etc. Then smart mobility, the electrical vehicle charging, infrastructure, supervision surfaces, traffic management, tunnel management, toll management, railway management, airport solutions, all come under smart mobility. Smart water system, the smart public services, smart buildings we already studied, and then smart data center and smart integration. Now, what is the scenario today? Over 40 global cities to become smart cities by 2020. Because of Corona, the speed is somewhat less now, but more than 50% of smart cities of 2025 will be from Europe and North America. Transformation of cities is possible by harmonic integration of infrastructure, citizen, and administration. How do they work? Buildings will be fully interactive with the power grid. We are talking about the smart grid system. Then walls and ceiling will be embedded with sensors, and every aspect of a building performance and use will be metered and measured. Software tools will be used to automatically optimize the building system without human intervention. Real-time information about the building that is relevant to their particular needs will be provided to the occupants and building manager. What are smart solutions? Smart solutions are application of IT and computers to municipal services and infrastructure to make them better. Example, smart water meter and billing system, remotely controlled automatic distribution valve, real-time online system of monitoring water quality, citywide intelligent video surveillance network, using mobile phone for cyber tour of the work sites. Now, this is a diagram here. You can see that different components. Smart energy, smart buildings, renewable energy generation is possible. Building integrated photovoltaics is possible. Smart mobility, smart technology, smart infrastructure, smart governance, smart healthcare, and smart citizen because use of green mobility options, smart life cycle choices, etc. Now, this is the occupant, system, and public sector and planning taken them together. How they integrate to develop a smart city. The key features are the backbone of cities operations, public and private convergence of information from different systems. Example, power grid, transportation infrastructure, water, waste recycling, traffic, security, all this is possible. Now, smart buildings, smart cities, and industry integration. Smart buildings, at least 50% of the building will be green and intelligent, built with building integrated photovoltaics, what we called as BIPV, 20% of building will be net zero energy building. That means their energy footprint will be zero. Smart infrastructure, multimodal transport hubs, providing air, rail, road connectivity to other megacities. Smart energy, about 20% of the energy produced in the city will be renewable, either wind or solar. Smart grid infrastructure, smart cars, at least 10% of cars will be electric with free fast charging station. Satellite towns, the main city center will merge with several satellite towns to become one mega city. And this is the smart city market, about the business value, how much the different costs are of the smart governance and all, how much will be allocated to which particular sector. Then there are integrators, that is system integrators, because we need to have different smart city integrators as project integrators. Then network service providers, pure play product vendors, and managed service providers, which will have a round-the-clock monitoring, complete management of the things. Smart city planners have 4 different models. One is BOO, that is build, own, and operate. Then build, operate, and transfer. Then build, operate, and manage, and open business model. This is already in place. People are doing it. Smart grid, this is the electric grid which uses information and communication technology to gather data and act on the information about the behavior of suppliers and consumers in an automated fashion. Hence, smart grid is a generic level for application of computer, intelligent, and networking ability to the existing dumb electricity distribution system. At present, we don't know that which grid is failed or which grid is good, which grids needs solar power. All this is possible with smart grid. It uses information technology to improve how electricity travels from power plants to consumers, allows consumers to interact with the grid, integrates new and improved technologies into the operation of the grid. Why smart grid? Because it will reduce the carbon footprint, improve the distribution management and decision support software, self-healing, automated control for distribution, sensing and measurement technologies, and increased efficiency. Some of the examples are timely visibility of external events, event information processed at the edge of the grid, insights delivered to the field workforce quickly, business-wide situational awareness, grid and asset management analytics, personalized customer support, and insight to the customers. The Government of India Smart Cities Mission Strategy is Pan City initiative in which at least one smart solution is applied citywide. Develop areas step by step. There are 3 models of area-based development. One is retrofitting. That means the buildings and infrastructure needs new infrastructure inbuilt in them. So retrofit them. Redevelopment and greenfield. Greenfield means totally new field where you can start making the city infrastructure. Citywide smart solutions, we have e-governance, citizen services, that is public information, grievance redressal, electronic service delivery, citizen engagement, citizen cities eyes and ears, and video crime monitoring. This will give you a e-governance. Similarly, there can be waste management, that is waste to the energy and fuel, waste to compost, wastewater to be treated, recycling and reduction of C&D waste, water management, smart meters and management, leakage identification, preventive maintenance, water quality monitoring, smart meters and management, renewable sources of energy, energy efficient and green buildings, smart parking, intelligent traffic management, integrated multimodal transport, And of course, there are telemedicine, tele-education already happening now, incubation and trade facility center, and skill development center. This all is possible with a city-wide smart solution. You can have your own decisions or smart solutions based on the area-based development needs to make the government funds more cost-effective. India has allocated nearly 6,000 crore for development of these smart cities. Here is the list of cities that has been proposed by Union Cabinet to be upgraded to smart cities. Now these are the states. You can see Chhattisgarh, we have Raipur, Atal Nagar and Bilaspur as smart cities. There is a further talk going on to include Korba and 2-3 more cities into this. And this is the decision taken at the central level, and the smart cities and different authorities have started working in these cities to make the cities smart. So here I come to the end of my presentation. Thank you.
Thank you, sir.
Yeah, you have
Thank you,
any
sir.
question? Yeah.
Yes, sir. Thank you, sir, for this informative session and your thoughts on design of smart buildings to planning of smart cities were to the point. And you rightly mentioned that smart infrastructure provides the foundation of for all of the key things related to the smart city, including smart people, smart mobility, smart economy, smart living, smart governance, and a smart environment. So now moving forward, I request all the participants to join the discussion and ask questions. They can either raise hands or they can post a question in WhatsApp group. I request all the participants to ask the question. I request all the participants. Yes. So there is a question in WhatsApp group, sir. The participant is asking that smart cities challenges lie predominantly in making the people smart more than anything else. Is it? Are you agree with this, sir?
No, no. The thing is that people smart is not much necessary. You have a plug and play devices and all. Yes, but some kind of basic training is needed. At present, what you are seeing in the smart city development is basically they are improving the urban infrastructure, and they have not come up to that stage where you need that people should be uh, trained to use the smart features. For example, let us say there is a parking and there are dots available in which it will assign that these parking spots are vacant. So at present, infrastructure is not developed up to that level. After that, yes, there is a need of training imparted to the people who are using these facilities to use them smartly. That means smart technologies can be used by them in a better manner. Otherwise, a costly facility will go waste.
Yes, thank you, sir.
Neeraj Verma is raising hand.
Yeah, please ask.
Please ask the question, sir.
Good afternoon, sir.
Yeah, Neeraj sir, बताइए.
Okay. Sir, my question is that the old cities in India, which are not planned and or developed in a chaotic manner, under those conditions, how can we provide the that is the smart city related infrastructure?
Yes, Neeraj ji, that's a very relevant question. There are actually two things into the old city. First of all, is there any heritage value? If there is any heritage value, then it is a component of smart city to develop heritage based planning to that part. That means heritage walk, heritage preservation of the things and all. Otherwise, the old city retrofitting is possible. In our second goal, we have the old city retrofitting measures, which is generally being taken by other smart cities, Nagpur, etc. They are taking the old city development as their priority. So yes, that is definitely a part of smart city development. We will not see that everything will be greenfield. There will be brownfield development, and that is actually improving the urban infrastructure of the old cities.
Okay, thank you so much, sir.
Thank you, sir. So I thank all the participants for the active participation, and to the this session. Yes, Agrawal sir.
Indrani, lots of disturbance is there. So, is there any more question?
Yes, I can see here in the WhatsApp chats.
So we can take some more
Yes,
questions if it is
yes,
there.
So one of the participants is asking that how about the financial contribution of the state and central government towards the development of smart cities?
Yeah, actually, the smart city project initially is funded by central government. Uh, what they are saying, that project is in two parts. The first part is over, in which they have funded. The second part is you have to meet halfway. That means 50% of the cost will be borne by the central government and 50% will be the state. And there will be revenue generation activities within the smart city, which will start as a payback facility, and that will ultimately make the smart cities self-reliant on their own. So this is the total project idea of Government of India.
Thank you, sir. There is another question from the participant. Is there any smart solution rather than providing IoT-based solution because technology have its limitations?
This is actually opposite. IoT-enabled solutions are not practiced at present. That is the problem. People are taking the smart city mission as a conventional way to improve their urban infrastructure. है ना? Like what they have been doing in a JNURM, that is Urban Renewable Mission kind of thing. The solutions, smart solutions, are not taking care of the IoT based solutions at present, but it should also integrate IoT based solutions. Technology has its limitation, we understand, but thing is that if your planning, if your infrastructure is not up to the mark, technology will be also failing to help you there, and other people will develop faster than you if you are lagging behind in this infrastructure. That's why the smart city missions are trying to first take up the urban infrastructure in a required level and then start with the IoT based solutions.
Thank you, sir. There is one more question. On what basis cities are selected for being the smart city?
On what basis the
Cities are selected?
Cities are selected? Yeah. Actually, every state has to send in a proposal to the central government that this is the potential of the city, which will be ultimately becoming a smart city. There is a competition organized within those, and then the cities were selected. This includes people participation survey, feedback survey also, and those surveys were taken, and the progress of the smart cities is also monitored by the competitions at various levels. It is not that arbitrarily they have selected that this is one city we should be smart. It has been taken that their potential to develop, their employment generation, their economy generation, their infrastructure generation potentials are taken up, and only then they are within the list of those smart cities.
Thank you.
In this regard, I can also say that what happened in Chhattisgarh, Raipur was contesting for becoming a smart city. But the Naya Raipur, which is now known as Atal Nagar, was not contesting. Then I had a chance to meet those administrators, and I asked them that why you are not contesting. You already have so many features. They said that we are already having smart features. Why should we need money? But then afterwards, when they saw the total outlay of the project, they also participated in the competition, and now that's why we have Atal Nagar also reflecting as a smart city mission in the list.
Thank you, sir. So if there is any other question, participants can ask. So I guess we don't have any other question in chat box as well. So we have come to the end of this session. Thank you so much, sir. Sir, so with your permission, I can conclude the session. Agrawal sir.
Okay, Indrani.
Yes.
Okay. So, Sanyal sir, thank you very much for your
Thank you.
time.
Thank you.
Very nice presentation. We could get in nutshell the smart city and smart buildings, both the things. You got the idea. What are these things and how you integrated these things? That was very nice. Thank you very much.
Actually, it must have been a long day for the participants also, right from 9 o'clock
Yeah.
to this. No problem. Any kind of query or anything, you can then WhatsApp or email me. It's not a problem.
Okay.
Coordinator. And I thank you for the giving me the opportunity to this kind of prestigious program. Thank you very much.
Thank you very much.
Thank you, sir. So I want to extend my generous thanks to Dr. Debashish Sanyal. I want to thank the guest to give his vital time from his busy schedule to grace this occasion. I want to thank the speaker for sharing with us his graceful opinions. Thank you so much, sir.
Thank you.
Thank you, sir.
कल के लिए अनाउंस कर दो.
Yes. So participants, we will be gathering here tomorrow at 9 a.m. The first session will start from 9 o'clock. Thank you very much for the participation. Thank you. And the link will be same for all the sessions.
Feedback from not there, madam.
Yes, ma'am.
Feedback form.
About feedback form, Vivek sir will tell better. There will be the feedback form at the end of the FDP. We are taking the attendance in every day's session. So there will be feedback.
Feedback form is there on the AICT portal, Atal portal. So last day that will be initiated actually, and feedback will be entered only on the last day. Okay.
Thank you, sir. Okay.
Feedback is not to be given on daily basis. Okay.
Okay.
At last, you will have to enter that feedback. After feedback, your attendance and performance in the test. All these three things will be there. Then only